eduwebtvkpm.
Hello everyone and good day to you. You're now watching Success STPM 2021 together with me, Sean Stephen, as your host. Now for those of you who will be sitting for your STPM, specifically for this paper, Mathematics T3, now you better pay close attention because today our guest teacher will be sharing with you on how you can answer your questions correctly for you to score really good for this paper. But before that, let's have a look at our teacher's profile. And joining us today is Mr. Bupati. He is the head of unit for Science and Maths for Form 6 from SMK Tun Habab Kota Tinggi, Johor. Hello, Mr. Bupati. How are you today?
Fine, Sean. How are you?
I'm great now that you're here. But maybe I can ask you this question. What will be our focus for today?
I will be focusing on important aspect and how to guideline to answer all the question in 6 chapters. Sean.
All right, great. And what about this segment here? What will be our focus for that?
For this, we will start with our segment with data description.
Okay, great.
Okay.
So, over to you.
Okay. Thank you, Sean.
Thank you.
Okay. So, students, before we continue with our first chapter, let us see a few points first. Okay, all the students, please take note of the following aspects. Okay, aspect 1. Numerical final answer must be given correct to 3 to 5 significant figures unless stated otherwise in the questions. So you must be very careful that anything less than 3, more than 5, consider wrong.
Okay.
Okay, next important point is, during our discussion throughout the session, every step that being emphasized must be shown in your working. Otherwise, mark will be deducted. I will be using example to demonstrate this. Okay, next one. Able to define certain statistic terminology based on the context of the question. Sean, okay?
Okay so far.
Okay.
Yeah.
Let us continue with the first chapter. Okay, in this chapter, data description, we have 2 subtopics. One is group data, another one is ungrouped data. For these 2 parts, okay, what you have to know is you should be able to calculate measure of central tendency and measure of dispersion and use correct formula and able to use algebraic operation on both MOCT and MOD. Next part, you have to calculate standard deviation and mean by using sum of x minus a and sum of x minus a squared and calculate combined mean and standard deviation for at least combination of 2 or 3 set of data.
All right.
Next, you have to construct and interpret stem plot, box plot, histogram, and cumulative frequency curve. Last part of the chapter, you should be able to describe the best way to describe the distribution of a data, whether it is a symmetry, positively skewed or negatively skewed. For this, you can use 5 ways. 1, using MOCT. Next, you can use quartiles. The third one, you can use box plot. The next one, you can use histogram. Or lastly, you can use Pearson coefficient of skewness. Okay, well, students, for group data, the major mistake found among the students. Okay, so in group data, if you notice that, so if you notice here for the table 1, the value from 74 to 75, there is a gap here.
Yes.
Whereas for year to year, no gap, if you notice here. So from this, you should know that the 70 actually shows you, and the 29 year, the 70 shows you class limits, whereas the 29 shows you class boundaries. So these two is very important because if you do mistake here, then your MOCT and MOD will be totally wrong.
Okay.
Okay, for example, we take for this thing particularly. If you notice here, Sean, you
Yep.
can see here 1,000. So this one, student usually assume as 70. It's actually 70,000.
I see.
Okay?
Okay.
Whereas here, if you notice, this is in 100 cm.
Okay.
So that means this one actually shows you 2900.
Aha, all right.
So what happened is here, if you see clearly, the class interval for this one, students tend to write 5 because they can find the class interval here is 5.
Yes.
But actually what is the answer is, John?
5,000.
5,000.
Okay.
So this one small mistake, you can end up doing mistake for all your calculation.
Oh, no.
So same thing goes here.
Okay.
So if you notice here, the class interval here also is 5. Okay?
Yes.
But student will tend to write 5. But must careful that this is in 100 cm. So your class interval will be 500.
I see.
So this is very common mistake among students.
Okay.
Okay, must be. Okay, we continue with one example.
Okay.
Okay, which I will emphasize certain things. Okay, let us see one example. Okay, the mass in kilogram of 25 students is given in the table here. Okay, so your first task is determine the first, second, third quartiles. Carefully, first, second, third quartile, ends. You must be very careful the word ends. That means you want to comment the skewness, you must use these 3 values. You cannot use anything else. You cannot use MOCT or you cannot use box plot.
Okay.
You must use the 3 values. Okay, comment on the distribution. And then B, state the suitable measure of central tendency and give reason. Okay, so if you notice, so first we have to find the 3 quartiles. Then we have to comment.
Okay.
Then we have to determine the suitable measure of central tendency, and then we have to give reason. Let us check the working. So before you can do the first part, you have to rearrange your data. You have to rearrange your data. Okay, after you rearrange your data, your Q1 will be 7th observation, which is equal to 43. Your Q2 suppose be equal to 13th observation, which is equal to 55.
Okay.
And then your Q3 is equal to 19 observation, which is equal to 62. That means each one you will get 1 mark.
Okay.
Okay. The most important is your indication here. So you are using Q1 is equal to 43. Maybe some student wondering, what happens, sir, if I use small q? Okay. It's okay. It's acceptable.
Okay.
Okay. Then we continue. So the next portion of the question, the next task, they ask you to comment on the distribution. Okay. So since we are finding these quartiles, so we need to find a difference between the quartile first.
Okay.
We need to find difference between quartile. That means Q2 minus Q1, Q3 minus Q2. You find, you show your working, you get 12 and 7 here.
Yeah.
Okay, you get 12 and 7 here. Okay. Then you have to do comparison.
Okay.
You have to do comparison. That means you do comparison that Q2 minus Q1 is greater than Q3 minus Q2. You do comparison.
But what happens if you don't do this sentence or this line here in particular?
If let's say you never do this, okay, and then you never do comparison, you straight go for your answer. Let's say, Shona, see first. So your answer will be negatively skewed distribution. If let's say the student never write this, they only do these 2.
Okay.
Then mark will be deducted. Mark will be deducted. Okay. If let's say they never do this, never do this, never do this.
Yes.
They straightforward give you correct answer, negatively skewed.
Okay.
That means mark will be 0.
Ah, I see.
So the working is more important.
Okay.
The method of obtaining your answer, give with the reason.
All right. Okay, and looks like, oh, but I do have one more question over here.
Yes,
For
sure.
example, here, the data has negatively skewed distribution. But what happens if we do not include that word negatively over there?
Okay, so if you notice here,
I'll just tap on the screen.
okay, if you notice here, Sean,
Yes.
the statement will be the data as negatively skewed distribution.
Yes.
But the most important word here is negatively skewed distribution.
Yeah.
If you fail to write the word negatively, mark will be deducted. That means this one will be wrong. Even though your working year is correct, but this will be wrong. Because skew means we got two types of skewness.
Yeah.
One is positively skew, another one is negatively skew.
Okay.
So if you never write the word negatively, it might be positively skewed.
I see.
Okay,
So
so
therefore,
that's
that would
why.
be the wrong answer for
Yes.
that. Now, what about this statement over here? The data has negatively skewed distribution. So if let's say I do not put the word negatively over there, can that be accepted?
Sean, you listen carefully here.
Okay.
We got two types of skew distribution.
Yes.
One is positively skewed, another one is negatively skewed. What happens if you never put the word negatively mean? It might be positive also.
I see.
That's why if the word negative there is very important. So your answer must be negatively skewed distribution.
Okay.
Okay, shall I continue, Sean? Okay?
Yes, please.
Okay, so in next part, they ask you what is the suitable measure of central tendency. So based on our answer here, actually, we know already. Once it's a skew distribution, the best measure of central tendency is median.
Okay.
Okay, median. Maybe some student will write mode is acceptable, okay? But median is the much more better. Okay, then we continue. They ask you to give a reason. So the reason here is very clear. You can write the data as negatively skewed distribution.
Okay.
Which means, if you never write, let's say you never write here negatively skew, okay, for this particular part, if you write just skew distribution, is good enough already.
I see.
Because the skew here shows that you must use median. Whether it's positively skew or negatively skew, you must use median as a measure of central tendency.
All right, great. And right now we'll be taking a short break and we're back to you for Success STPM 2021.
DidikTV KPM. DidikTV KPM.
You are now watching Success STPM 2021 for the subject Mathematics T3 together with Mr. Bupati and of course me, Sean Stephen, as your host. Now, Mr. Bupati, what will we be focusing on for this segment?
For this segment, Sean, we will go through two chapters.
Okay.
One is probability, another one is probability distribution.
All right.
So I start with probability first.
Okay.
Okay. This is the most difficult chapter among students.
All right.
Okay. Because they are unable to differentiate between combination and permutation, using correct formula related to the correct events, and then they cannot use a probability statement with correct set notation.
Okay.
Let us see here. Okay, for this chapter, they must know well to explain three of the main terminology. Okay, one is mutually exclusive events, another one is independent events, another one is conditional event. So I will go through one by one all the events in this chapter and all the related formulas.
Okay.
Okay, first one is composite events. So here we got three main formulas. As you can see, Shauna, very clearly is written there.
Yeah.
Okay. So next one is mutually exclusive events. Students should be able to explain what is mutually exclusive events. Here we got all together 6 different formulas,
Okay.
which you should be able to use in context of the question. Later we will see in example. Okay. Our third event is independent events. So here we got 2 formula, which students should able to interpret and use it well, according to the situation.
Okay.
And next event is conditional event. For conditional event, we got 2 main formulas. Okay. And last event where students study is rules of total probability. Under rules of total probability, you got 1 formula. But if you don't like to use this formula, you can use 3 diagram.
Okay.
Much more easier to get your answer.
All right.
Okay. But what I noticed so far in my experience of teaching, students always show weakness in translating or converting probability statement into set notation. Once you convert to set notation, you can use a proper formula to find the value.
Okay.
So let us see some of the important. Before that, let us see how to prove 2 events are mutually exclusive or independent. Okay, first one is mutually exclusive. Okay, to prove 2 events are mutually exclusive, you can use either one of the 4 ways. Okay, student can see clearly in the boards one of the 4 ways.
Okay.
Or if you want to prove independent events, you can use either one of the three formulas. Either one enough already. Okay, you can prove. But once come to the next part, okay, set notation for probability statement, of course, student shows very weakness. Okay, Sean, this one is, of course, most of the student cannot do.
Oh, no.
Okay, so let us see some of the main terminology. Okay, let's say probability of A and B. So this one is indicated by A union B. So the set notation we use here is union.
Okay.
Okay, which stand for OR. Next one is probability at least one of A and B occur. So for this, at least one, that means the set notation still remain the same, A union B. If you notice, different terminology, but the formula still remain the same.
Yes.
Okay, next, probability A and B. So the key point here is N.
Okay.
So this is indicated by A intercept with B.
Okay.
Then probability of both A and B. So the key word here is both. So we get same set notation. Probability of A intercept with B. Next, one of the event. The key point here is one of the event. That means only A occur or B occur.
Okay.
So which can be shown by using the formula PA intercept B prime plus PA prime intercept with B. Next one is probability both A and B does not occur. So clearly can see both A and B does not occur.
Okay.
Okay. So here we can see very clearly A intercept with B. Why A intercept with B, Sean? Because of the both.
Yes.
Does not occur, prime.
Prime. That's right.
Okay, then we continue. Next one, neither nor.
Okay.
Okay, neither nor mean here very clear. Okay. A union B prime. So you can see the difference. Both A and B does not occur and neither A or B. Slightly different. Okay, the last one is probability A given that B. So this is actually come under conditional.
Yes.
Okay, under conditional, this one is A, probability of A slash with B. Okay, let us see one example, Sean. Okay, one example where I try to apply all the probability statement.
Okay.
Okay. Two events, X and Y, such that the probability is given. So once you see like this, of course, you know this is conditional events.
Yes.
Okay. Then question is, find the probability that. Okay. The key point is here. Okay. So the key point is here, both. So once students see the word both, they should be able to use intercept. Okay. Then next one, if you notice B, they ask you to find both do not occur. That means if you don't know the formula, you cannot answer this question.
I see.
Then next one, only one of the event occur. So to answer these three part of the question, you need to convert the probability statement into set notation.
Okay.
Okay, so let us see. Question A, because both, so I use A probability X intercept with Y. Okay, so I use the main formula. So this one you get from just now formula. I
Yes.
list all the formulas.
Okay.
So we substitute 3 over 4 times with 1 over 2, and then we get 1 mark there, and then my answer 3 over 8, I get 1 mark. So
Okay.
you get 2 marks. Very straightforward question. But the condition, you should be able to convert the statement.
Okay.
Okay, next one, you want to find based on the statement is P X prime intercept with Y prime. Okay, so for this, our formula, we use formula based on what I told you just now. So we use the formula, and then you get 1 mark by using correct formula.
Okay.
Maybe you're wondering why you never get here formula, because very few marks.
Okay.
So depend to the mark. Okay, total mark awarded. So here we use this formula and we substitute the values, all the values, and then we get answer is 17 over 57, 1 mark.
Now I have a question over here. We see
Yes.
for part B, right? The first 2 lines over here, we show the formula. What happens if we don't show the formula and straight away just show the values or put in the values?
Thanks, Sean. Okay, if you never write these 2 formula, but you got substitute inside the formula correctly,
Yes.
without any mistake, the mark can be embedded here.
I see.
So this mark actually will go here.
Okay.
Okay, the mark will go here.
All right.
Okay, Sean? Okay,
Alright,
we continue.
Yes.
Okay, in question C, we want to find neither one. Okay, so P x intercept y prime plus with P x prime intercept with y. So we use correct formula. So you using, because this is considered difficult case.
Okay.
Difficult, so you get 1 mark for using correct
I
expression.
see. Yes.
If you don't know to use the set notation, that means totally you will be wrong here.
Okay.
Okay, then we substitute inside the formula correctly, we get 1 mark. And then my answer is 9/28, which will give you 1 mark. So total here is altogether 2, 3, 3, 8 marks.
All right.
Okay, we continue, Sean. Okay, our next chapter is probability distribution. This is the longest chapter in the syllabus. Okay, longest chapter and more frequently will come out in session B. So in this session, for this topic, we got 5 different parts. The most easiest is the first part.
Okay.
Discrete random variable, DRV. For DRV, is actually the very basic. Okay, you should able to use the properties of DRV. Next part, you should be able to calculate probability using PD and CDF, and then you should be able to obtain CDF from PD and PD from CDF.
Okay.
And then at last part, must use correct formula to evaluate or calculate mode, median, variance, and standard deviation. So this one is much more simple because we only use here summation mostly.
Okay.
Most of the cases we using summation. The next part of the chapter is continuous random variable, CRV. For this, Sean, if your integration, which you study in second sem, is very poor, then you cannot answer question in this part.
Okay.
This is basically involving integration.
Okay.
Okay, calculus, what you study in sem 2. Okay, so for this one, first of all, you need to know the properties of CRV. Okay, 2 properties. And then you should be able to obtain CDF from PDF and PDF from CDF. And then calculate probability based on integration of PDF. And then use graph in the case of linear function. And then you can use CDF. 3 ways to obtain your probability. And then the next one, you should be able to calculate median, quartile, mean, variance, SD by. Here we got 4 steps. First, you have to define the formula correctly with correct limit of integration. Second thing, you must do your integration properly. And then next one, you should integrate and substitute your value. And the last part, you will get your answer. Okay. Next one, we will study 2 types of distribution which come under DRV, binomial distribution and Poisson distribution. These 2 are considered slightly easier. So here you should be able to define condition for a random variable x for having binomial distribution or Poisson distribution. And then able to define the correct formulas. And then able to find mean and expect a mean and variance using the correct formulas. And then the last part, you should be able to solve problem involving this distribution. But when solving problem involving this distribution, you have to state your random variable, state your distribution, list your probability one by one, and use correct formula to evaluate them.
Okay.
Okay. The last part of this chapter is normal distribution. In normal distribution, you got 2 things. One is to solve problem related to science and technology. And for this, you have to define your random variable and state the distribution. You need to use correct symbol of inequality involved and standardize. Okay, next, you should be able to sketch the normal curve and shade the required region. And show the correct usage of CDF. Here, Sean, mostly students never write this thing.
Okay.
They tend to use calculator and lose mark. Mark is deducted. Okay?
Alright.
And next thing, determine the probability by using table or calculator. In next part of this chapter, we will use an approximation for binomial distribution. That means we will use normal distribution as an approximation for binomial distribution. Almost identical to just now, but slight different. So first, we have to define the binomial distribution. Next part, we have to show the transformation of the distribution. That means we will transform from binomial distribution we will transform from binomial distribution to normal distribution by stating the condition and calculate the mean and variance.
Okay.
Then after that, it's all follow exactly like just now.
I
No
see.
different at all here. So you have to sketch the normal curve, shade the required region, show the usage of CDF, and last, you have to determine the probability by using table or calculator.
Okay.
Okay, we see one example here, Sean. Okay, this is one long question which come out in session B.
Okay.
15 marks.
Oh,
If you can
that's a
answer
lot.
this one question, is considered very good already. 15 marks out of 60.
Wow.
Okay.
Okay.
So the mass of guava, okay, is given something like that. So the percentage of guava that are less than 400 gram is 15.87%. More than this one is this 6.68%. Okay. So determine mu and lambda, and find probability that guava has a mass at most 500 gram, given that it is more than 400 gram. And then in next part, this is got one officer, he go and do something. Okay, so he said that the number of guava in the branch of the tree may be modeled by a Poisson distribution. May be modeled by a Poisson distribution.
Okay.
Okay, so Poisson distribution, he gives that Py0 is equal to this one. Find the parameter of the Poisson distribution. If the student don't know what is parameter, they cannot answer this question. Okay, student should able to understand what is parameter.
Alright.
Okay, then give two reasons why Poisson distribution cannot be an exact model. Here we do with Poisson, but here we say why cannot use Poisson.
Okay.
Okay, just explanation. Okay, so the keywords are, this is the one. Okay, parameter, reason. Let us see the solution. Okay, I back to just now. Okay, if you notice, Sean,
Yes.
we got here mathematical probability statement. Probability statement, probability statement, where
Yeah.
student have to convert into symbols.
Okay.
Okay. So first, they write x is less than 400. The probability given 15.87, so become 0.1587.
Yes.
Next one, greater than 500, you get something like that.
Okay.
Okay. So once you can convert the statement into mathematical symbols like this, you get your first mark.
Okay.
Okay. Then of course, just now I mentioned to you. Okay. Just now I mentioned to you that you have to standardize.
Yeah.
That means here also we standardize. We have to show this, John.
Okay.
Okay, standardize. Then here also we standardize because both are we doing the same things. So 1 mark is given here.
Alright.
But both must be correct.
Okay.
Okay, next, what we do, as what I mentioned earlier, we sketch the normal curve, we mark the indication here, then we get my value here is equal to -1.
Okay.
So that means I know this whole thing is equal to -1.
Alright.
Okay. Then same thing I do here, I draw the diagram, and then I get something like that. So if you notice here, Sean, the student must get here -1 and form one equation here. That's
Okay.
why you get 1 mark here.
I see.
Here, you have to form one more equation based on the value 1.5.
Okay.
So you got 2 equations. So they need to rearrange the equation. So from here, we rearrange. Okay, this one we rearrange. We got 2 equations here. Okay. And then what we do, we need to find the value. We got 2 simultaneous equations here.
Yes.
So we have to solve the simultaneous equation. We show the method. Then we come to our answer. Mu is equal to 440.
Yep.
And then my
Lambda,
sigma is equal to
sigma,
40.
sorry.
Sigma is equal to 40. So 1 mark here, 1 mark here.
Okay.
Okay. So if you notice here, Sean, changing into the probabilistic statement into a symbols is very important, as what I mentioned earlier. Okay. Standardizing. Okay. Using correct diagram here, then get your answer.
Okay.
Okay, in part B, we asked to find probability.
Yeah.
If I go back to earlier part, if I just want to show the thing to you, Sean.
Yeah.
Okay, if you notice here.
Oh, back to the
Okay,
question.
so
Yeah.
if you notice here, find the probability that guava has mass of at most 500 gram, given that, if you still remember just now, I got used the word.
Conditional, right?
Yes, conditional, correct, Sean.
Yes.
Okay, given that. So that means this is a conditional statement.
Okay.
So we must use, go back. So I have to convert my statement into symbols.
Okay.
Mathematical symbols.
Yes.
So I use correct formula here. Okay. So convert the statement using correct formula here, mark is given. Using correct formulas.
Okay.
Okay, next. Of course, here I need to do standardization.
Yes.
But in the question earlier, they already give probability for x is 400 and x is 500.
Yep.
So we no need to standardize the things. So we can use formula here, the diagram.
Okay.
Okay. So what happened? I interpret from here because you want to find probability for this. So all together is equal to 1 minus with this probability and minus with this probability.
Okay.
Okay. Because these values we already given.
All right.
Already given. So I substitute inside because from year to year no marks because we just applying only. Okay.
Yes.
So we substitute correctly all the values, we get 1 mark, and then my answer I get 1 mark.
Okay.
Okay. Then the part C. In part C, okay, they give you this one. They ask you to find the parameter, but students should understand that parameter mean because this is Poisson, you need to find lambda.
Okay.
You need to find your lambda. Okay. So your lambda here, so we use the formula, useful result. This is I call as useful result. So use useful result, you get e to the power of negative lambda is equal to this one. Then we try to solve it. Okay. So we use ln. Okay, we solve. And then we get answer 2.35. Okay, Sean, I go back here one more time, Sean.
Yeah.
I get my exact answer here is 2.35.
Okay.
Okay. If let's say the student write 2.4 because he round up here,
Okay.
your answer will be wrong. Because I told you just now, numerical value must be at least 3 significant figures. 3 to 5.
3 to 5.
3
Yes,
to
that's
5.
right.
So
yeah.
the best value is 2.35 because after this all 0.
Yes.
Okay, so this is the best answer. Okay, next. Okay, they ask you to give reason. So if I mentioned earlier, for binomial and Poisson distribution, you should be able to state their conditions.
Yes.
Okay, condition for what is properties of Poisson distribution. But in this case, they are asking, why never follow a Poisson distribution? That means you must find the negative statement for that.
Okay.
You must find negative statement. So what happened? For Poisson distribution, if you notice here, in guava trees, the branches won't be equal in length.
Yes.
For Poisson, everything must be equal in length.
I see.
So, if you write, okay, branches, the key point here is not equal in length. You will get 1 mark.
Okay.
The next one, for Poisson distribution, the properties is Poisson distribution can go until infinite. But in guava tree, in a branch, the most we can have is a finite number of guavas.
Yeah.
We cannot have until infinite number of guavas. So that's why the second reason is finite.
Okay. And if the students are able to answer this question correctly, they get a total of 15 marks, correct?
Yes.
All right. And right now we're going to take a short break. And back to you for Success STPM 2021.
DidikTV KPM. DidikTV KPM.
And we are back on Success STPM 2021 together with me, Sean Steven, and also Mr. Bupati with the Mr. Bupati, my mistake, with the subject mathematics T3. And what will be our focus for this segment?
So this year we will do 2 chapters. One is sampling and estimation. Another one is hypothesis testing.
All right, over to you.
Okay. So for sampling and estimation, these are the terminology which the student should be able to define in context of the questions.
Okay.
Okay. For sampling, so this chapter got 2 main parts. One is sampling, one is estimation.
Yes.
For sampling, the student should be able to find and describe every aspect about sample mean and sample proportion.
Yes.
Okay. Let's say one example, simple example. Okay. The standard deviation mass of steel sheet in a batch of production is 5.67 kilogram. A random sample 100 sheet drawn from the batch. Okay. What is the population concern? Next one, determine the distribution of the sample mean.
All right.
So we want what is the population. Okay, so as what I mentioned earlier, so you define. So population refer to all steel sheet produced in the batch of the production.
Okay.
So this mark you only can obtain if the word all is seen.
Yes.
If no all, you cannot get this mark.
Okay.
If let's say you write population refer to steel sheet produced in the batch of production, you won't get that 1 mark.
Okay.
Okay. So next one, they ask you to give the distribution. In order to get distribution, you must do 3 things. First, you have to state the conditions. Okay. So what is the condition here? Okay. The sample size is large enough. Here the sample size is 100 by using CLT. So you can use CLT, stand for central limit theorem.
Okay.
Okay. So this is your condition. So then we determine what is the distribution. So the distribution here is normal distribution. So X bar as normal distribution.
All right.
Okay. Then we have to state the parameters. So what is the parameter? This is the parameters.
Okay.
So here clearly shown that this one and this one will give you 1 mark.
Okay.
The distribution is approximately normal. You will get 1 mark, and then your parameter you will get 1 mark.
All right.
Okay, we continue. Okay, to solve problem regarding sample mean and sample proportion, very easy. We just follow these 3 simple steps. Okay, these 3 simple steps. That means you have to define the distribution, and then you use the step 3. You need to find correct mathematical symbol at what I mentioned earlier. You standardize, sketch the normal curve, and determine the value required.
Yeah.
Okay. Underestimation. This is the second part of the chapter. Underestimation, we must know 2 things. One is point estimation. In point estimation, you must find unbiased estimate. You need to find unbiased estimate for population mean. Okay, which is shown something like this. And then you need to find for variance, population variance. And then you need to find for population variance. Actually, this is the standard formula.
Okay.
All these formula derived from here.
Okay.
The student should be able to know, okay, this one derived from here.
Okay.
Okay, the next one is proportion. So for proportion, okay, we got only 1 formula, simple formula.
I noticed that each of these formulas have a cap of some sort on top of the symbol.
Okay, Sean, if you notice, if you write like this one shows you the mean of the population.
Okay.
If like this mean, this is unbiased. That means we using sample value
Okay.
to implement to the population.
I see.
So 2 different things.
Okay.
Don't confuse. Okay.
Alright.
So when you find unbiased estimate, you must have your cap there.
Okay.
Okay. We continue. Next one, interval estimation. Under interval estimation, you need to find 2 things. You have to determine and interpret confidence interval for population mean using this formula, and then population proportion by use this formula. Okay, I no need to explain the formula because all of you should know.
Okay.
Okay. Then step involved in confidence interval for population mean and population proportion are the same. Okay, you got 6 steps here. Okay, step 1, identify the distribution of the what you are referring, whether population mean or population proportion. Then step 2, you determine the value of Z score based on the given values, okay, given confidence level. And then you need to determine the margin of error. Some use E, some use H, doesn't matter.
Okay.
But the formula remain the same. Okay, the first one is formula for population mean. The next one is formula for population proportion. Okay, next we have to construct by using this formula. Okay.
All right.
Then step 5, we have to make statement. So how to make the statement is like that. For example, let's say that one is 95% confident. So you have to write a 95% confident interval for mu is this one. That means the standard wording is like this. You just have to fill up your confidence level here and then your value here.
All right.
So easier for student to remember. Okay. And then interpret your interval. Interpret means we are making conclusion. How to make your conclusion? Okay, the way of doing conclusion is I take from above. We are 95% confident that the mean mass of the durian, because we are dealing with mean. So mean mass of the durian is between this one and this one. We open back this one from interval form.
I
Direct
see.
statement.
Okay.
So that means the interpretation should follow this pattern.
Yes.
Always will follow this pattern. Okay. So effect of sample size and confidence level to the width of the interval. So this one you should know that when sample size increase, your width of the interval will decrease.
Okay.
Okay. So we want to make the interval become much more narrower. Okay. So when confidence level increase, your interval width also will increase.
All right.
Okay. So narrower is much more better.
Okay.
Okay. We continue. Okay. Next chapter is hypothesis testing. Okay. In this chapter, we are going to test two things. One is population mean, another one is population proportion.
Okay.
Since this one involves a testing, it must follow certain procedure.
All right.
If you never do any of the procedure properly, you will lose marks.
Okay.
Simple as that. So you have to know what are the steps one by one. Okay. Let us see one by one. What is the steps? Okay. What is the main key terminology you should know in context of question? So these are the mainly come out in exam, the 4 terminologies.
Okay.
Okay. So next one is population mean. Okay. How to test population mean? Very easy. 6 steps. Whenever you come across any test, remember these 6 steps. First one, you define your mu or sigma, where you need to state your null and alternative hypothesis. Okay. In step 2, select the distribution. Okay. By assuming H0 is true. This is our H0 and H1, but here we assume the H0 to be true.
Okay.
Then in step 3, we need to find critical value, critical region, okay, based on the significant level and type of the test. We got 3 type of tests, left tail test, right tail test, two tail test.
Okay.
Okay. So let's assume our significant level here is 5%.
Okay.
And LTT stand for left tail test.
Okay.
Right tail RTT. Okay. So let's say this one. So my critical value for this will be like this. And then my critical region for in the form of interval.
Yeah.
Then I make a early decision. Early decision we call. That means H0 is rejected if my test statistic is less than my critical value.
Okay.
So this step you must have 3 things. 1, 2, 3 things. Okay, 3
Alright.
things. Then we continue. In step 4, you calculate the test statistic. Okay, this is very simple. Just apply the formula. Okay, let's say, I assume that my test statistic is negative 2.091. Let's
Okay.
assume. Okay. So in step 5, we will make decision based on step 3 and step 4. Okay. When doing the decision, actually, if you notice on,
Yes.
we got 3 layer statement.
All right.
Okay. What are the 3 layer statement? If you notice here, okay. First, we have to do comparison. Comparison. Okay. After comparison, from the comparison, what is our result?
Okay.
Then we do decision here.
I see.
So 3 layer statement. So that's why I put here the way of writing. Always must be 3 layer.
Okay.
Okay, then continue. Last step, you must do a conclusion. Okay, based on step 5, whether you reject or do not reject H0. So if you, let's say if H0 is rejected, you have to write at alpha % significant level, there is sufficient evidence. That means if not rejected, at alpha % significant level, there is insufficient evidence that. Okay, so these 2 are important things when you do a conclusion. You must have the word significant level and then evident or significant level, insufficient evidence.
But what happens, like you mentioned earlier, we have to follow the steps. But let's just say we skip a step, but our ending or our final answer is correct. Will anything happen then?
Yes, your mark will be deducted.
Okay.
A mark will be deducted. That's the
Alright.
main thing. Okay, it's not wrong. Mark will be deducted.
Okay.
And population proportion also, we got 2 cases. One for small sample size. Okay, the way of doing remain the same. It's not much different.
Yes.
Same like what we did in population
Population mean,
Same.
yeah.
It's nothing different.
Okay.
Okay. You can read here. So we are using here binomial. For less than small sample size mean less than 30. Less
Okay.
than 30, we will use binomial distribution.
Okay.
So slightly different in our test statistic here. Okay. For large sample, for large sample mean must be greater than 30.
Yes.
This one is almost identical to, the 6 steps are almost identical. Only slight different here, we are using normal distribution. That's the difference.
Yes.
Just now we use binomial. If large mean, we are using normal distribution.
Okay.
Okay, let us see one example.
Okay.
Okay, this is a question regarding hypothesis testing. Okay, so this one regarding mean age. So I are testing mean. Okay, at least 44 years. So this is the key point, Sean, here, 44 years. At least 44 mean must be greater equal to 44, which means that one shows you null hypothesis.
I see. Okay.
Okay. Then the mean age of the random of 36 patient is 42.6. And then they give you standard deviation. They say, carry out a test. That means you know this is hypothesis testing.
Okay.
Okay. 5% significant level to determine whether there is evidence that the doctor claim is true. You want to test whether the doctor claim is true.
Okay.
Okay. So we let mu is equal to mean age. Okay. So as I mentioned just now, we got 6 steps. So step 1, we write our hypothesis.
All right.
Null hypothesis and alternative hypothesis. Okay. So this where students always do mistakes. This one. Because if your sign is, you got 3 possibilities. Either will be greater or not equal or less than. Okay. Different symbol will come out for different tests.
Okay.
But for your H0, you can use equal sign. Doesn't matter.
Oh.
Always equal sign.
All right.
Easier. Okay, so first step, you get 1 mark. Then you define the distribution for X bar by assuming H0. We assume this one is true. Okay, so our critical value, our critical region based on what is given 5% significant level. So our early decision, we will reject this. Okay, so step 3. So in step 4, okay, I find my test statistic using correct formula. I substitute inside my formula, okay, and I find my value is equal to negative 1.61, negative 1.68. Then in next step, as I mentioned earlier, Sean, if you notice here,
Yes.
3-layer statement.
Okay.
Comparing, based on the comparing, what is my result? Then from the result, what is my H0 is rejected, my decision. H0 is rejected. So I get 1 mark here. Writing all that, I get 1 mark.
All right.
Okay, so my conclusion is, at 5% significant level, there is sufficient evidence to reject the doctor's claim because H0 is rejected. Okay, or you can write like this. At 5% significant level, there is insufficient evidence to conclude that the doctor claim is true. Basically, we are rejecting the doctor claim. So this is how you write the 6th step when you're answering exam question. That's all, Sean, for this part.
All right. And right now, we're going to take a short break and we'll be back to you for Success STPM 2021.
DidikTV KPM. DidikTV KPM.
You are watching Success STPM 2021 for the subject Mathematics T3. Now over to you.
Thank you, Sean.
Yes.
Okay, for in this session, we will go through chi-square test, the last chapter.
Okay.
Okay, for this chapter, these are the 5 terminologies students must know very well in
Alright.
context of the question. Okay, we continue. Here we got 2 types of tests. One is goodness fit test. Okay, same like what I mentioned earlier. Since this is a test, you got 6 steps.
Okay.
You follow the 6 steps. Only slight different here and there. So step 1, we state the H0 and H1. But here H0 refer to the theoretical value or distribution. That means goodness fit test is to test your distribution.
Okay.
Okay. H1 does not. That's all very easy. Here we don't have any symbols. Does not. That's only word we use.
Okay.
Okay. And then step 2, by assuming H0 true, we calculate the expected frequency by using the formula NP. If your expected frequency is less than 5, we combine the adjacent group, as I shown in the table below. Okay. So in this table, if you notice, expected frequency here we calculate by multiplying this one with the total frequency here. So you get 3.62, which is less than 5. So we combine these two, which will give us okay, 16.07.
All right.
Okay. Then we add these two, we get here 15. So this is how you combine the adjacent groups.
Okay.
Okay. So once you do like this, we must remember that earlier we got altogether 7 columns, but now become 6 columns already.
Okay.
Okay. Then what we do, step 3 is slightly different here because we need to find degree of freedom. Only different is degree of freedom. Other than that, everything same like hypothesis testing. Okay, we find degree of freedom because 6 column minus 1, I get 5. Then by using the table, I find the critical value. And then I state the critical region and I make my early decision.
Okay.
Okay, so this is my early decision. In step 4, I will calculate test statistic, but slightly different from just now. Okay, so we state the formula and then we make a decision. Decision, as I mentioned earlier, 3-layer statement.
Okay.
Okay, 3-layer statement. Okay, as what I shown here. Same thing if your this is not rejected, this is rejected cases. Okay. In step 6, we will do conclusion. Okay. So let's say our test statistic is 13.31 and my test statistic, this is my critical value. I do comparison. Once I comparison, my result is test statistic fall in rejection region.
Okay.
Then my conclusion is H0 is rejected.
Okay.
Based on that, I do conclusion. Okay. So my conclusion will be at alpha % significant level, there is sufficient evidence that I follow what is required in the question.
Yes.
Okay. Or I can write like this. Sorry. Okay, I can write something like this. Significant level, there is insufficient evidence. Only the 2 words can be used. No other word can be used.
Okay.
Okay. Then test of independency in contingency table is basically we are testing relation between 2 variables.
All right.
Okay. Basically, the 6 steps here remain almost identical, but the way of writing H1 is slightly different. You use independent, no association, or not related.
Okay.
But the H1 will be independent, not independent, no association, association, related, not related. That's how you write.
Okay.
Okay. So the step 2, we find our construct contingency table and we find our expected frequency. So we can write the expected frequency in our table. It's said next to the corresponding value.
All right.
Okay. How to calculate? Okay. Of course, you know row total times with column total divide by 20,000 here. So you get this value. So you do same thing for all the cell here. This one we call cell. Okay. So in step 3 onward. Okay. Step 3, step 4, and step 5. 3-layer statement still same. Okay. And then our conclusion also remain the same. We never do any changes. The way of doing still same. Okay.
All right.
Okay. So for one example, so this question, 200 adult smokers asked whether they agree to quit smoking. The results are shown in the table. So they show here. Okay. The researcher claimed that the smoker respond toward the quit smoking is ratio 4:3:1. That means this is the distribution.
All right.
That means this one come under goodness fit test.
Okay.
Okay. Determine at 5% significant level whether the researcher's claim is justified, whether it's true or false. Okay. So what we do, as I mentioned earlier, 6 steps. Okay. Okay. So H0, we just write because this is the distribution, we just write. Okay. And then for your H1, just the word not. Everything same exactly. We only put the word not.
Okay.
Okay. That means first one we agree, next one we not agree with that. Okay. And then we get 1 mark there. We find our expected frequency. So our expected your total frequency here is 200. So based on the 200, we calculate our expected frequency. So we get 80, 60, 40, and 20, and total is 200. So if you notice here, all the values here are greater than 5. That means you don't need to combine.
Ah, yes.
Okay. So we continue again. Okay. So you get 2 marks here. 1 for to getting the blue values there.
Okay.
Another mark all correct.
I see.
Okay. Okay. So next one, step 3. Okay. You need to find degree of freedom because you got 4 columns. So 4 minus 1 is 3. You find your critical value. You get 7.815 from the table. Then your critical region. Then your early decision. It's almost identical.
Oh, yes.
Okay. Then we continue with our, if you notice, for this lot of things, you get only 1 mark. Where is the mark depend? Okay, depends. Maybe they can give here, they can give here, they can give here, or everything got, then only you get this 1 mark. It depends to the situation.
Okay.
So that we calculate the test statistic by using formula. Using this formula is much more easier.
Okay.
Okay. So we calculate. So we get answers 6.505. So finish our calculation part. So now we make decision. Now we make decision. So our decision, as I mentioned earlier, Sean, 3-layer statement. Okay. So this is my value. Okay. This is my critical value. I do comparison. My result here. Then this is my my decision. H0 is not rejected. So if H0 not rejected, so at 5% significant level, there is, if you notice, keyword must have. So the researcher's claim is true.
Okay.
Because we are not rejecting H0.
I see.
That means my researcher's claim is true. Or maybe this is the best way of writing.
Yeah.
Okay, maybe the student will write like this. Maybe. They like to use the word insufficient. So at 5% significant level, there is insufficient evidence to reject the researcher's claim. Slightly different, but both bring the same meaning.
All right. Thank you once again, Mr. Bupati, for sharing with us how we can answer our questions correctly to get the maximum marks. And for those of you who are going to sit for Mathematics T3, all the best to you and take care, and we will see you soon.